All right, let's take a look at part 2 of 6.6. So let's continue our journey. This time we're going to look at logarithms or solving logarithmic equations. So in the first part, we looked primarily at exponential equations. Let's take a look at number 7. So right here, we've got ourselves a logarithm. Okay, now remember, in the first part, since we dealt with exponents, we had to have the bases be the same in order for us to set the exponents equal to each other. So we also mentioned the first time that in order for us to solve logarithms, that the log bases have to be the same. So let's see what we could do right here on number 7. I've got myself 2 is equal to log base 3 of 4x. I can't get x by itself. I can't, remember, log base 3 of 4x, it's not like multiplying where, hey, let me just divide both sides by log base 3. It doesn't work that way. What we have to do right here, and we saw stuff before in, I think earlier on in like 6.2 or 6.3, is let's go ahead and I'm going to take that 2, it'll now become an exponent, and 3 will be its base. And I will repeat that same thing right here on the right side, where 3 will now be the base raised to the log base 3 of 4x. And so what that allows me to do is, let's go ahead and we'll simplify things up. Let's take that 3 squared. That'll now become 9. And then 3 raised to the log base of 3 power. The log disappears. And now all that's left is that 4x. And so what we can do now is get x by itself. We'll divide both sides by 4. And x is equal to 9/4. Now there is a key thing right here that I had highlighted up at the top sentence for the instructions. It says check for extraneous solutions. Okay, so how do you do that? Remember, you take your solution, plug it in. Okay, plug it into the equation and see if it works out, because there are times where it will not work. All right, so that's why they have explicit instructions. Check for extraneous solutions. For the sake of our time, I already know, hey, I plugged that in and it works out A-okay. All right, let's take a look next up at number 8. I've got ln, and then I got x squared of x squared plus 3, and then I have equals to ln 4. Remember, if the logs are the same, then I can go ahead and just take whatever they're equal, set them equal to each other. Or sorry, take the terms and set them equal to each other. The same occurs with ln as well. If I have ln on both sides, what I simply can do now is go ahead and take x squared plus 3 and set that equal to 4. And let's go ahead and solve for x. Okay, we'll set this equal to 0. Now, once again, I can do this right here because I've got just ln on both sides. They have to be on both sides of the equal sign in order for me to do that. Okay, so let's go ahead, now that we have that taken care of, let's set this equal to 0, and x squared minus 1 is equal to 0. We have to solve for x. Okay, I guess there's 2 ways. I could have actually got x squared by itself, and it works out in this instance because now I know how to solve a problem like that. So let's go back right here, because the way I had it set up, I could factor and solve. Okay, remember, that's always one way. This is a quadratic, so I could use the quadratic formula as well. But this question is pretty basic, so I could go ahead and subtract 3 to both sides and then get x squared by itself. Last step, let's square root both sides. and x is equal to, now this is where students get half credit or no credit because this is plus or minus 1. And that's why the first time around I set set the problem equal to 0, because then, hey, at least hopefully you'll know, all right, if I use the quadratic formula, you should get 2 answers because plus or minus is already embedded into the equation. Or you see that, hey, that was factorable, and you would have factored it into x plus 1 times x minus 1, and then you get your 2 answers of positive and negative 1. So if you're one that does not remember, does not forget that, hey, when I square root both sides of an equation, I have 2 solutions, then go right ahead and solve it how I just had it right here. But remember, that only applies, most of this primarily applies when we're solving equations, not when we're just simplifying an expression. Okay, we don't usually put both plus or minus down. All right, so let's go now to number 9. I've got on one side, I've got log base of 8 is equal to x squared minus 5 is equal to 2/3. All right, well, I got to get rid of that log base of 8. There's only one thing I can do here, and I will turn that into an exponent and have 8 as my base right here. And the same will apply over here on the right hand side of the equation, and I got 8 raised to the 2/3 power. Let's go ahead and simplify things out. The log, or 8 raised to the log of 8, that'll become bye-bye. And now I'm left with x squared minus 5 is equal to 8 to the 2/3 power. And 8 to the 2/3 power right there, plug that into your calculator. You should be able to do that without a problem as long as you use parentheses. Make sure you could also rewrite this as the cube root of 8 squared. They are both the same. So let's see right here, 8 to the 2/3 power. And all of this right here simplifies down to 4. All right, so things are looking good. I love it when a plan comes together. It says Hannibal on the A team. And so I'll go ahead and add 5 to both sides, and x squared is equal to 9. We go ahead at the final part, we go ahead and square root both sides, and x is equal to 3. But don't forget, plus or minus 3. Is that my answer? I don't know, because what do you need to do next? Plug them both in to see if one is extraneous, or if they are extraneous. I'll tell you right now, fast forward, plugged it in, they are okay. All right, so we're good there. Let's move along to number 10. All right, this one gets a little tricky. Remember, if we take a look at, for example, like number 8, because we had an ln on both sides, that automatically made things so much easier with our life, and the ln's disappeared because it's like the log bases are the same. Okay, think of it that way. The log bases are the same. But right here on the left hand side, I've got 2 ln's, 2 expressions with ln right there. That gives me a little bit more work for this problem. Okay, now in 6.5 we talked about like the product property, and the product property was that you add the product. When you have the product, you add, right? And so we have these 2 ln's, which are technically logs, right? They're natural logarithms, and we go ahead and we're adding them. But when we add things up, it is the same thing as multiplying. So we're going to combine these 2 together and turn this into ln x times x plus 2. And I want to go ahead and simplify this next. And I've got ln x squared plus 2x. Okay, so now that we have that, we can go ahead and work on the right-hand side, which there isn't much to do now. All right, I'll go ahead and just put this down as ln x plus 6. See, now number 10 looks similar to that of number 8. I've got ln on both sides. So here, I can go ahead, since the natural log base, they're the same, I'm going to now just go ahead and set this problem and set the expressions equal to one another. And so I have x squared plus 2x is equal to x minus 6. And so now at this point in time, we go ahead and take all of this. This time we are going to have to set it equal to 0. Okay? Because it's not just a binomial. So I got x squared. I'll subtract x to both sides, and I got ourselves plus x, and then minus 6 is equal to 0. And so now you got several options. You could factor. You can complete the square. You can use the quadratic formula. One of the three. A lot of times these questions are set up so that you can factor things out. So let's go ahead and factor this. Remember, factors of negative 6 that add to positive 1. And that right there would be x minus 3, or negative 3 and positive 2. We set these equal to 0. We get our answers as x is equal to 3 and also negative 2. But don't forget, one of our steps here is to make sure we check for extraneous solutions. So you need to take both of your answers, plug them in, make sure they work out. Okay? Plug them in, make sure they work. All right? So, I'll tell you what. This 3 right here, hold on 1 second. Let's go back to our factoring. Sorry. This right here should be x plus 3 and x minus 2. Okay, and then so when we set this equal to 0, x is equal to negative 3, x is equal to positive 2. So if you caught that mistake, cheers, good for you. And so once again, we check for extraneous solutions, and negative 3 happens to be extraneous. And so you only have one answer here, and make sure you only give one answer on the test. Otherwise, it's how I find out that you weren't paying attention and getting extraneous, or checking for your extraneous answers. All right, next up, number 11. Okay, so on the same side of the equation, we have two logarithms, just like on number 10. But this time we have a subtraction. Remember, when we subtract logarithms right here like so, that is the use of the product property. Or sorry, quotient property. Oh, I'm tired. I'm getting off my rocker now, huh? So we have ourselves the quotient property in use right here. All right, so with the quotient property, it's because we have the minus sign in between the two logarithms, and the log bases are the same. All right, so that will allow us to go ahead and rewrite this as log base 2, and then let me go ahead and change this to x plus 5 over x minus 2, and that is equal to 3. I got to get rid of the logarithm so I can now solve for x. So we've had you have experience with this, with some of the problems we've already solved for. And in order for us to get rid of a logarithm, we have to make sure that what it is of is same as the log base And there you go. We're going to go ahead and put 2 as the base of in both sides. So 2 raised to the log base of 2 goes away. I'm now left with x plus 5 over x minus 2, and that is equal to 9. Or sorry, we have ourselves, it's not 3 to the second power, it's 2 to the third power. And that right there is equal to 8. So let's get to work. Let's get x by itself. What we have to do right here is, we could cross multiply right here to help us solve this problem out. So what I'm going to go ahead and do next is remember this 8 right here is the same thing as 8 over 1. Okay, so I'm going to go ahead and put right there 8 over 1. And so if I cross multiply, then what I end up with is, I've got x plus 5, because I'm multiplying that by 1, right? Cross multiplying this way. And then when I cross multiply with the 8 and the x minus 2, you're going to be distributing the 8, and you're left with 8x minus 16. So at this point, you can go ahead and just get x by itself. So I'll subtract right here x to both sides. So I have 7x, and I'll add 16 to both sides, and that becomes 21. And looky, divide both sides by 7. We got ourselves a whole nice number. X is equal to 3. And that right there is your answer. So we've taken a look at quite a few different examples here, right? It's taken a little bit more time to solve these problems out. We had, 6.6a was like the little appetizer, and then now we're getting into the nitty-gritty. Next up, solve the inequality. We have log is equal to, or log of x is less than or equal to 1/2. There are several things for us to think about here. Okay, for one, we got to figure out how to solve things out. 2, you've got to understand this, that because look at the equation, it's log of x is less than or equal to 1/2. So you can get answers here, right? You can get whatever answer you want. There's going to be lots of answers because of the inequality. But maybe with your calculator, what happens if you put in like log -10? What ends up happening? You're going to get an error. It doesn't work. Because remember, when we graph things, at some point, these logarithms, remember, they reach a point of an asymptote. And that it won't go beyond that, the asymptote, right? So we have to set up boundaries, especially right here, when the x happens to, when we have an inequality where it's x is less than or equal to a particular number. All right, so let's go ahead and put right here, I'll put like a little addition, that log 0 or less is undefined. Right? When we have log base 10 of 0 or anything less, it ends up becoming undefined. So that's why right here on these problems, we must set a boundary. So let's see what happens here, okay? What do I need to do? Now remember, when it's a logarithm by itself, then that means the log base is 10. So what I'm going to start off doing is put 10 as the base, and now log x and 1/2 now becomes the exponent. So that gets rid of the 10 and the log, and now we have x is less than or equal to 10 to the 1/2 power. Okay, I can go ahead, maybe it's going to be easier if you go ahead, if I rewrite this as x is less than or equal to rad 10. So what I have to do here is this. Because of the fact that if in my problem here, if you take x and you set that, it's got to be greater than 0, right? So we take this part right here and realize that x must be greater than 0. I have another part of my boundary. And so my answer right here, now, because what you might see there is like log x plus 5. And so you're going to have to take x plus 5 and set it equal, greater than or equal to 0, or greater than 0, due to our asymptote. So my final answer is a combination of all of what I just showed you right now. X is less than or equal to rad 10, but x also needs to be greater than 0. And there you have your answer. Once again, think about a graph. If you were to graph this out right here, log x, and see what happens, eventually, you have that line and it comes to asymptote, and it doesn't work. So that's why we must make sure we have these boundaries. So make sure you check for it. Now, if right here, if the equation was log x is greater than or equal to 1/2, hey, you don't have to worry about an asymptote there, or at least setting the other side of the boundary, because you're not going to get undefined. If you're uncertain of it, hey, just start plugging in numbers into a calculator, and then you'll be able to see it. One last problem. I guess this section makes up for 6.6a. We'll take a look at 13. Always love these word problems. Now, this one talks about Newton's law of cooling, which there was a specific equation to use right here. And let me go ahead and give that to you if you didn't look at it in your book. So we have T, and then we have T sub 0 minus T sub R. We have times E negative RT power plus T sub R. So we have some new things here that you're probably not very certain of. You're saying, hey, I've never seen this stuff before. And let's talk about what some of these variables are. T sub 0. Now remember, when it's sub 0, in science and in mathematics, it's always like the initial. Okay, so this will be initial temperature. We have T sub R. That right there, they told us is room temp. And I think the last one right here that we do not know is T, which happens to be our target temp. That's what we want to reach. Think about, like, hey, when we talk about boiling, right? Boiling water needs to reach a certain temperature. Freezing water needs to reach a certain temperature. So it says, your parents buy juice for a graduation party, leave it in their hot car. Oh no, terrible. It might even go bad, right? When they take the cans out of the car and move them to the basement, the temperature of the juice is 80 degrees Fahrenheit, which is not very cool, right? I don't know if you'd want to drink something 80 degrees. The room temperature of the basement is 60, and the cooling rate is 0.147. Hopefully it makes sense. Use the variable R, right? So we're going to use the Newton's law of cooling to figure out how long will it take for it to cool the juice to 63 degrees Fahrenheit. It's probably going to take a while, right? That's why we have modern day refrigeration, so we don't have to do this kind of stuff. All right, well, let's see what we could plug things in, right? That's what it's all about. We have right here, I see 63 degrees. That looks like target temperature to me, because that's what we want to hit. So we'll plug that in for T. Initial temperature, that's what time we get or the temperature that we have things at, and that looks like right there 80 degrees. Right, so we have initial temperature. That's what we're starting with. We have TR, which is the room temperature. Luckily, we know that that happens to be right here. That is not the highlighter. We've got room temperature of 60 degrees. So I'll go ahead and put 80 minus 60. We've got E raised to the negative, and then we go ahead and put R there, and they gave us R being 0.0147, and then T is our target temp, right? We don't know what T is other than the fact that it is our target temperature. And then finally right here, we've got ourselves plus T sub R, which is our room temp, which is a number that we already used, and that is going to be 60. So let's use all the skills that we learned so far in this section and solve for T. You got your order of operations, so there's certain things that you can and cannot move. We can move this 60, right? I'll subtract that to both sides. 60 minus 3, we got ourselves, or 63 minus 60 is equal to 3. 80 minus 60, that's going to get us 20. And then we have ourselves E to the negative 0.0147 T. What next? Hopefully you already know. Let me divide both sides by 20. Okay, I can do that next. So I'll divide both sides by 20. And so now I have 3 over 20 is equal to E. All right, to that exponent right there. And now we got to get T by itself somehow. That E's in the way. Well, at this point, it's just an exercise of remembering our steps and putting everything together so you can solve things out. And I'll multiply both sides by ln. So now I've got ln 3 over 20 is equal to negative 0.0147 T. And so for our last step to get T by itself, we'll go ahead and divide both sides by negative 0.0147. And we now have our find our T, our answer. Sorry, T being time. I think I mentioned because this is lowercase t, not uppercase t. T being time. You go ahead and plug that stuff into your calculator, and you should get your answer. This right here takes approximately 129 minutes. 29 minutes, or 129.06 minutes. Since we're not talking about minutes and seconds, this whole answer ends up being in minutes. And there you go. We have now finished 6.6. Sorry this one took so long, but hey, that's why we split this up into 2 days. We'd be here forever, right? So go ahead and try your best on the homework. Make sure if you have any questions, ask me. Send me an email. Come to tutorial. You name it. Bye-bye.